So we are still doing what we were doing yesterday. Remember, our first step is to isolate the absolute value. Second step is to set up two separate equations and get our solutions. And it reminds us, be sure to check your solutions. We've got to go back and plug them in. So remember, there's a few different things that could happen. They could both work, like the example we just did from yesterday, don't work. They could both not work, and my answer would be no solution. Or I could have one work and one not work. And then we would have one solution and one extraneous solution. Okay, so starting with number 1, do I have to move anything? No, we already have the absolute value by itself, so we're good. So I'm going to write down my first equation, 2x plus 12 equals 4x. So there's my positive answer. So my second equation should be 2x plus 12 equals what? Good. Alright, so there's my two separate equations. One with a positive answer, one with a negative answer. And now we just solve each one of these. Alright, so what would I do first for the 2x plus 12 equals 4x? Okay. So then I'm going to have 12 equals, good. And then the last thing I would need to do is, good. So I end up with x equals 6, right? Okay, I got some confused looks there. So we're ignoring this one for now. She said that we should move this 2x over here with the 4x, which is right? We got to get all of our variables together. 4x minus 2x gave us 2x. Those went away, so all that was left was 12. And to get the x by itself, since 2 is being multiplied by x, we had to divide by 2. Those divided out, and 12 divided by 2 gave us. Alright? Okay, now we've got to do the same thing for this other equation. So what do you guys want to move first there? Okay. I'm going to subtract 2x from both sides. So those will go away, and I'll have 12 equals, good. Alright, and then to get the x by itself, what do I have to do? Good. And what is 12 divided by negative 6? Negative 2, good. So these are my two solutions. And what do I have to do with those? Check them. So I'm going to have to plug them in to the original problem. Absolute value bars and all. So I'll have the absolute value of 2, but instead of x, I'm going to plug in 6 plus 12 equals 4. And then there's another x over here, so I also have to plug in the 6 there. Okay? So I simplify over here first. What is 2 times 6? 12. So inside my absolute values, I have 12 plus 12, which is, okay, so I have the absolute value of 24. And on the other side, I have 4 times 6, which is 24. And is the absolute value of 24 equal to 24? Yeah. So that one worked. We're good there. All right, now I'm going to do the exact same thing. This time I'm plugging in the negative 2. Which phone's up? So I've got 2 times negative 2 plus 12 is equal to 4 times negative 2. So I'm going to simplify my absolute value first. What is 2 times negative 2? Negative 4. And what's negative 4 plus 12? the absolute value of 8 is equal to, what's 4 times negative 2? Okay, and is that true? Right. So I had one that works, so that one is a solution, but then I had one that did not work. Yes? Shouldn't the 4 on the second one be negative? 4 on the second one be negative. Where? No, we plug it into the original every time. Okay. Alright, so this one did not work, and if you remember from our definitions yesterday, we said that that meant it was extraneous. That's what happens when you have one that does not work. Alright. Okay, so on number 2, can you guys attempt that one for me, and then we'll check it together? Alright, so first I would set up my two equations. My first one, I leave it as it is. Alright, so I have 4x minus 1 equals 2x plus 9. And what was my second equation?
4x minus 1 equals negative 2x minus 9.
Perfect. Okay, now I just have to solve both of these like we would any normal equation. So on the first equation, what did you guys move first? Okay. Alright, and 4x minus 2x left us with 2x, right? Then I had to move this one to the other side. And what is 9 plus 1? So I had 2x equals 10. Then I just divide by 2, and I end up with x equals 5. Alright, so there's my first solution. Now I gotta solve the second equation. So maybe you started it the same way, moving the 2x. So this time I'm adding 2x. And 4x plus 2x is going to give us, and then I have to add the 1. This time when I add 1, I get good. Alright, and then I divide by 6. And that's not going to come out a nice neat number. It's going to be a decimal, right? So I'm going to leave it as a fraction. But this will simplify, right? They're both even. So I can simplify this to x equals negative 4/3. Okay. Now that I have my two answers here, we have to check. So I'm going to plug in the 5 to this first equation. So I'd have the absolute value of 4 times 5 minus 1 equals 2 times 5 plus 9. Okay, so inside my absolute value, 4 times 5 is going to give me, and 20 minus 1 is, so the absolute value of 19. Over here I have 2 times 5 plus 9 gives me, so is that a true statement? Yes, so we're good there. Now I have to do the same thing with the negative 4/3. I'm plugging it into the original. So I'm going to have 4 times negative 4/3 minus 1 equals 2 times negative 4/3. I'm running out of room there. Plus 9. Okay? So I have 4 times negative 4/3, which is going to give me, yes, negative 16/3. But then I have to subtract 1, right? Well, if I wanted to convert this into something where I could actually do that, I just need to rewrite this as a fraction. So that would be negative 3 over 3 would be the same thing as negative 1. So negative 16 minus 3 is going to give me negative 19. So I end up with negative 19 over 3 inside my absolute values. Alright, and over here, I have 2 times negative 4/3, which is going to give me negative 8/3, right? So I have negative 8/3 plus 9. And what is negative 8/3 plus 9? 19/3. So is this a true statement? Yes, because this is asking distance from 0. So in this case, both of these are solutions. All right. Okay, number 3. Can I start setting up my two equations just yet? What do I have to move? Okay, I cannot leave this on the same side as my absolute value. So he's right, we got to move this. Which actually kind of works out nice for us because that's going to make the 3x over here go away as well. Right? So now I'm only worried about the absolute value of 9 minus 2x equals 19. And now I can set up my two separate equations, right? So I have 9 minus 2x equals 19. And my other equation would be perfect. So all we had to do was make this one negative. All right. Now I'm just going to solve. So I'd probably want to move the 9 here. How would I do that? Good. So I have negative 2x is equal to, okay, and then I just divide, right? And that's going to leave me with x equals, good. All right, so there's my first solution. Now I got to solve this one. So I'm probably going to start the same way by subtracting 9. Okay, and what is negative 19 minus 9? Good. So I have negative 2x equals negative 28. All right, now what should I do? Good. And a negative divided by a negative is going to give us positive what? Good. Okay, so there's my two solutions. Now all I have to do is check them. So I have to plug them in to the original. So I'm going to have 3 times negative 5 plus the absolute value of 9 minus 2 times negative 5 equals 19 plus 3 times negative 5. All right, we want the left side to simplify to be the same as the right side. So over here, I have 3 times negative 5, which is going to give me negative 15, but I can't add it to this just yet. All right, got to simplify inside of there. So multiplication first. Negative 2 times negative 5. What's that going to give me? 10. So I have 9 plus 10, which is 19. So all this became 19, and it is inside the absolute values. And how far is 19 from 0? 19. So I just have plus 19 equals, over here I've got 19, and then what is 3 times negative 15? Times negative 5 is negative 15. And what do I notice about these two? They're basically the same thing, right? When I combine them, they're going to be the same. So this one did work out for us. All right, now I have to check it with 14. So I have 3 times 14 plus 9 minus 2 times 14 is equal to 19 plus 3 times times 14. Okay, and what is 3 times 14? Okay, so I have 42 plus, inside of here I've got negative 2 times 14, negative 28, so I would have 9 minus 28. What is 9 minus 28? Negative 19. So inside of here, I have negative 19, but it's inside the absolute values, right? So how far is that from 0? 19. So I get to pull out just a 19. Equals, over here I have 19 plus, again, 3 times 14, which you guys said was 42. So is this a true statement? Yes. So both of these are solutions. Okay. So we did have to divide by 5. So now I'm going to have the absolute value of 4w minus 1. If I actually divide by 5, 5w divided by 5 leaves me with 1w. And 40 divided by 5 gives me 10. So this is what I'll use to set up my two equations, right? So I'll have 4w minus 1 is equal to w plus 8. And then I'm going to have another equation that says 4w minus 1 is equal to... Good. And then I just got to solve these. So over here, what do you guys want to move first? The 1w or the 1? The 1, okay? So I add 1. So now I'm going to have 9 over here, right? That means I got to move this w over with the 4w. So I subtract it from both sides. And 4w minus w leaves me with 3w. So I have 3w equals 9. And then I just divide by 3, and we end up with w equals 3. Right? So there's my first solution. Now we come over here, same idea. So maybe we move the 1 first again. This time, negative 8 plus 1 is going to leave me with, good. Now I got to move this w over here by adding. And 4 plus 1 gives me 5w, right? And then we divide by 5. So we end up with w equals negative 7 over 5. Okay, now I just have to check these in the original, right? So I would have 5 times the absolute value of 4, but instead of w, I'm going to plug in 3, minus 1 is equal to 5 times 3 plus 40. Well, over here I've got 4 times 3, which is 12, and 12 minus 1, which is, so all of this became 11 inside the absolute values. The absolute value of 11 is just 11. So I've got 5 times 11, and over here I've got 5 times 3, which is 15, plus 40. Well, what is 5 times 11? And what is 15 plus 40? So it worked out. Now I'm going to do the same thing with the negative 7/5. So I'll have 5 times the absolute value of 4 times negative 7/5 minus 1 is equal to 5 times negative 7/5 plus 40. Plus 40. Okay, so I would have 4 times negative 7/5, which would give me negative 28 over 5, right? And what is negative 28 over 5 minus 1? Yes, negative 33 over 5. And it's inside the absolute values, right? Okay. And how far is negative 33 over 5 from 0? 33 over 5, right? Just makes it positive. So I'll have 5 times 33 over 5 equals, over here, I've got 5 times negative 7/5. Well, 5 times negative 7 would give me negative 35. And negative 35 over 5 would give me negative 7. Or you could just cross out the 5's, right? So I would have negative 7 plus 40. Well, over here I can also cross out the 5's. So that gives me 33. And what is negative 7 plus 40? 33. So this one worked as well. So these were my two solutions. So they're either both going to work, both not going to work, or it could be something like number 1 where one worked and then you would label the other extremes. Alright?